Welcome back, pre-algebra, and we are in lesson 39, and we're going to talk about equivalent equations. Equivalent equations are equations where the solution is the same for both. So for instance, if I had x plus 3 is equal to 9, and x minus 3 is equal to 3, I know that 6 would fulfill this x here. If I subtracted 3 from both sides, this would cancel and x would be brought down and it would be equal to 6, right? I know that 6 plus 3 is 9. Didn't have to do a whole lot of work for that one. This one, I know that if I take 3 away from 6, then I'm going to have 3 remaining. I can pretty much do that in my head, but to verify it, I'm going to do the opposite operation. This would cancel. I would bring x down by itself, and this x would equal 6. Because x equals 6 in both of these equations, the solutions are the same. We would call these equivalent equations. All right. That's all that means. So whenever you have two equations that you're given, what you'll do, they'll ask, are these equivalent equations? And you'll solve them. And if the missing number, x, the variable, is the same solution for both of the equations, then yes, they are equivalent equations. If they do not match, then no, they are not equivalent equations. And that's all that is. It sounds like a mouthful and something fancy, but it's not. Right? And it kind of makes a little bit of sense when you think about it. They're just equations that have solutions that are equal. That's all it means. So let's move on to the addition subtraction rule for equations. Remember, just a couple lessons ago, I gave you a rule that said for equations, whatever you do to one side of an equation, do to the other. And that's to keep them balanced. If we don't do the same thing to both sides of the equation, then they're going to get imbalanced and the equal sign is no longer true. So today we're going to talk about the addition subtraction rule. And the addition subtraction rule is really the same thing. The curriculum that we use just takes it a little bit further and specifies addition and subtraction. So give me just a moment. I'm going to write that up here for you. All right, so here's the addition and subtraction rule for equations. Number one, the same number can be added to both sides of the equation without changing the solution. Number two, the same number can be subtracted from both sides of an equation without changing the solution. So basically, what this said right here. Do the same thing to both sides of the equation and the solution will remain the same. The equation will remain balanced. Whatever you do to one side of an equation, you must do to the other side of the equation, or it will affect the solution and will not remain balanced. All right, so let's do some practice problems and test out that. So here I have in 39.1, x minus 3 is equal to 7. So I am going to try to get x by itself, and to do that I'm going to take the opposite operation from negative 3 or minus 3. I'm going to add 3 because that's the opposite of subtracting is adding. So I'm going to add 3 to this side, but because I'm doing it to this side, I have to do it to this side to keep it balanced. This would cancel, and that would leave x by itself on this side, and 7 plus 3 would be 10. So now if I was to check my work, and it's always a good idea to check, I would substitute in for the value of x what our solution was. It would be 10 minus 3 is equal to 7. 10 minus 3 is 7, and 7 does equal 7, so this is correct. So let's try 39.2 and see what we have there. So in that one, we have n plus 3 is equal to 7. So because I have a positive, or I'm adding 3 right here, I'm going to do the opposite, and I'm going to subtract 3 so that I can get n all by itself and figure out what that is. But whatever I do to this side, I'm going to do to this side. Okay, that tells me what to do. So that cancels out, and all that's left over here now is n is equal to, and 7 minus 3 is going to be 4. So I can check my work to make sure that's right and say, for where the n is, I'm going to put the value of 4. 4 plus 3 is equal to 7, and 4 plus 3 is 7, and 7 does equal 7. Okay, remember when I told you that I want you to start thinking of an equation as less of a number sentence with a blank to fill in, and more of two sides that have to have the same value. That's what we're doing. We're solving this side, and we're solving this side. And the only time we do something to this side is when we add or take away or multiply or divide on this side, right? If I just keep the things that are already here together, that's not adjusting it, that's keeping it the same. But if I take something away, like I subtracted 3 from this side, that wasn't there already. That's something different from what was there. So when you do something different from what was there, or like in this case, it's the opposite. We added 3 here, so we subtracted 3 to get in by itself. Whenever you do something different from the original things that were there, you have to do it to the other side. So whenever I added these two together, it's everything that was already here, right? I didn't change anything. I just combined them because that's what you're supposed to do. You're supposed to keep these operations together to get the value of whatever is on this side. So let's do 1 or 2 more. Let me clear the page. So 39.2 says, oh, I'm sorry, we did 39.2. Let's do 39.3. It says y plus 3 over 4 is equal to 9 over 11. Okay, so now this is getting a little bit harder, right? So now we're using fractions to try to figure out what we have. I have a positive 3/4, or I am adding 3/4 to y. So I'm going to subtract 3/4 from y. So I can get y by itself. But if I take 3/4 from this side, I've got to take 3/4 from this side. So now I have y is equal to 9 over 11 minus 3 over 4. Well, I can't do anything until I find a common denominator and am able to combine these. So because 11 is prime, 4 has the factors of 2 times 2. There are no factors of 2 here. So all I can do is cross multiply. I'm going to, or not cross multiply, but multiply by the opposite denominator. So that's what I'm going to do. So y is equal to, and remember, I'm not doing anything different to this side. I'm just adjusting the denominators of what's already here. So 4 times 9 is 36, and 4 times 11 is 44. Minus 11 times 3 is 33, and 11 times 4 is 44. Now I have some values that I can combine. So I have y is equal to 36 minus 33, because 36 is the larger number and it's positive. My answer is going to be a positive 3 over 44. That's the answer. So you can check that the same way we did the others. I'm going to sub it in for the y. 3 over 44 plus 3 over 4 is equal to 9 over 11. Let's see. All right, so first I've got to change this. And the way to change this is by multiplying. This is 4 times 11, so I need to multiply this by 11. So 3 over 44 plus 11 times 3 is 33, and 11 times 4 is 44. All right. So I'm going to go ahead and combine this. Actually, I'm going to go ahead and multiply this by 4. 4 times 9 is 36, and 4 times 11 is 44. So now they all have the same denominator. So now I can say 3 plus 33, that's going to be 36 over 44 is equal to 36 over 44. And that is correct. So I know that this answer is correct also. Okay, this one was a little bit harder because we had to do some more steps, but steps we already know how to do. Let's try another one. 39.4. And this one says z minus 3 over 5 is equal to 2 over 10. So we've got to find the number that when we take 3 over 5 away, we're left with 2 over 10. So first, let's get z by itself. So we're going to add 3/5 to both sides. So this cancels, and what I end up with is z by itself over here, and 2 over 10 plus 3 over 5. Well, I know that 5 is a factor of 10, and the other factor of 10 is 2. So if I multiply this by 2, I should get a common denominator. So z is equal to 2 over 10 plus 2 times 3 is 6, 2 times 5 is 10. 2 plus 6, z is equal to 8 over 10. Okay, but that's not the final answer. The final answer is going to be a reduced fraction. We always have to reduce. So I can reduce this fraction to 4 over 5. So let's see if that checks out. So my original problem, z minus 3 over 5. So I've got 4 over 5 minus 3 over 5 is equal to 2 over 10. Well, guess what? 2 over 10, I can reduce that to 5, denominator of 5, by dividing the top and the bottom by 2. 4 over 5 minus 3 over 5 is equal, divide this by 2, I get 1, divide this by 2, I get 5. So 1 over 5. 4 minus 3 is 1 over 5 is equal to 1 over 5. So this is the correct answer. 4 over 5 is correct. Okay? And if I had put 8 over 10 in there, I would have come up with the same thing. It's just that I would have had to have increased this fraction to all have the denominator of 10. So it really it didn't matter which way I did it. Because I did it correctly, I would have gotten the same answer. But whenever you respond in Jupyter, you always want to respond with the most reduced fraction possible. Okay? And that is all that we have for lesson 39. I will see you in lesson 40.